What we saw last time was that if we were given this factorial problem with a really large n, like 500, was that we could apply this shortcut here. Which is that if we didn't know n factorial, but we did know n minus 1 factorial, then all we had to do was multiply that number by n. And what I want to do in this video is sort of apply that into a more concrete fashion by writing out some code. And so what I'm going to do is define a method using the keyword def. I'm going to def a factorial function. I'm just going to denote that with an f. F is going to stand for factorial. And it's going to take an input n. And so we want to kind of using this function mimic this observation right here. So what would that look like if we have this function f that represents the factorial? Well, what we want is first of all to multiply n by the factorial of 1 less than n. In other words, we want n times f of n minus 1. And all we're going to do, let's not do output, let's do return. We're going to return n times f of n minus 1. Right? This statement right here is the same as this statement right here. And for those of you who haven't seen this kind of thing before, where we define a method, where inside the method we use the method itself. Right? For those of you who haven't seen that before, it might seem kind of weird and you might be a little skeptical at first, which is very reasonable, right? It almost seems circular that to define a function f, we use f. Right? That's kind of like defining what a word means, but then using that word in your definition. Right? And let's kind of explore that skepticism a little bit, which is a very reasonable thing to suspect. Right? So let's say we did this example right here, right? Let's say I wanted to know the factorial of 500. Right? We don't know the factorial of 500, so we're going to put that into our f function. That's, after all, what we made f for, right? So we're going to say f of 500 equals 500. We're just going to execute this line of code right here, times f of 499. Right? And so that's going to be our first function call. Well, we don't know what f of 499 is, so we're just going to leave this function call, this f of 500 function call, to the side. Let's first answer what is the factorial of 499. Right, and so this method call, we're going to run this code right here with n equal 499 and do exactly as the method says. So we're going to take n, which is 499 in this case, and we'll multiply it by f of 498. So just to hammer home this concept, we don't know f of 498, and so we're going to leave this function call to f of 499 to the side for a second, right? We're going to leave it to the side for now, and we're going to answer what is for f of 498. And again, we're going to run this function with n equal 498, and the function tells us to output 498 times f of 497. Right, and this is going to continue on and on and on. And you'd hope that this stops somewhere, right? At some point, we want to have the answer, right? And so maybe you hope that we end at f of 1, right? We're going to keep calling f of n minus 1, right? So at some point, we're going to call f of 1. And when 1 equals n, that's going to look exactly like this. We're going to continue the pattern here. We're going to do 1 times f of 1 minus 1, which is 0. Well, you'd hope it might stop here somewhere, but like clearly it doesn't. We're going to call f of 0. Right, I'm going to again run this function. We're going to find f of -1. And we're going to ask what f of -1 is. Well, that's -1, plugging in -1 for n here. That's -1 times f of -2. And that is going to continue on and on. So as you can see, like the way we've set up this function, your initial doubts that this is a sort of circular definition were very much correct, right? We keep calling this function, but this function keeps telling us to call the function again. And so without some notion of stopping, we're just going to continue this cycle. And theoretically, this is never going to end, right? We're going to keep calling, we're going to keep subtracting 1 from n and keep calling f of that new number. And so this leads to this idea of something called, which we need here called a base case, right? We need, as the name suggests, some way for the function calls to stop at some base. And where to stop it comes from the intuition that really comes from the intuition of why we wrote this out in the first place, which was that 500 factorial was hard, right? Which is why we needed this little formula here to help us. And we defined this factorial function in terms of factorial on a lesser input. And 499 factorial is also pretty hard to solve. And so we need to put that into our formula as well. And so the whole point is like all these big numbers, factorial of these big numbers are very hard to solve, but on some input, the answer is pretty trivial. The answer is really easy. And that number right here is 1. And what I mean by that is that factorial of 1, right? Factorial of 1, which is literally 1, the exclamation point, is equal to 1 itself, right? That's the answer to 1 factorial. And so whereas these factorial values here are tough to solve, which is why we need this formula, factorial of 1 is easy. It's very easy. We just return 1. And so we're going to actually code that base case into our function here and say that if n is 1, then we do know the answer, right? Factorial of 1 is easy. We're just going to return 1. And so what's going to happen now? Right, so we're going to call factorial of 500. We're going to say leave that aside, called factorial 499. Leave that aside, call factorial 498. And we're going to keep repeating that process until we hit f of 1. But this time when we hit f of 1, we're not going to keep going down, right? These function calls never happen because we do know the answer to f of 1. Right, we're going to hit this line and we're just going to return 1. And so in essence, when we hit this 1 right here, we're going to return 1. And so the function that called f of 1, right, conceivably f of 2 called f of 1. Now we know the answer to f of 1, which means that f of 2 can solve itself, right? It doesn't need, this isn't some unknown number anymore, right? This is just 1 now. And so now f of 2 knows its answer. 2 times 1 is 2. And so this is going to return 2. This pattern is going to keep going on, and we're going to eventually be multiplying 2 by 3 by 4 all the way up to the point where we've solved f of 497. Right, so this is not an unknown number anymore. We know the answer to this number. I don't know what that number is. but it's going to be some number, some really large number. And so now we can answer what f of 498 is, return that, answer what f of 499 is, return that, and answer what f of 500 is, what we actually need.